Today we are going to show you some interesting WebOS ninjutsu that a few of us over at the Intrepidus group have been working on uncovering. Note that this video highlights issues in WebOS version 1.3.5. The specific vulnerabilities depicted in the video have been responsibly disclosed and remedied to the best of Palm's abilities. For those of you unfamiliar with WebOS, it is Palm's next generation operating system for the new Pre and Pixie handsets. Palm tried to revolutionize the mobile platform space with WebOS. Essentially, the mobile platform itself is a web browser, and the mobile applications are written in JavaScript and HTML. As such, many mobile application developers that may not be familiar with common web application vulnerabilities have started to introduce these types of vulnerabilities into their WebOS applications. This new class of pseudo web mobile application vulnerabilities may expose handset users and the networks they reside on to unnecessary risks. We're going to show you some interesting use cases that highlight how common web application vulnerabilities within the SMS client of the device could have been performed remotely by an attacker on an unsuspecting user's handset. As you may have guessed, we will be using SMS messages as our attack vector. We will be sending these messages via laptop. However, anyone can send these attack strings from any SMS client. This first attack string quickly reveals the web application vulnerability we're exploiting. Rendering of unsanitized user input leads to HTML injection. This proof of concept inserts a Google.com iframe within the SMS message. We see that WebOS handles this new iframe by launching the phone's web browser. It is pretty obvious that this kind of behavior can lead to some seriously inappropriate, even malicious web pages being loaded due to reading a single SMS. Tisk, tisk, tisk. Our next example will leverage the same HTML injection bug to cause the device to start downloading a file using all available radio bandwidth. In this instance, the .doc extension forces the WebOS to inform the Doc Viewer app to handle the HTTP request. The Doc Viewer app will start to download the doc before it tries to display it. You can tell the data has begun to download when the network icon lights up. This slows all normal data usage for the user down to a crawl, as well as uses up any monthly data allowance the user may pay for. For this example, we're just downloading random data to the device. When we terminate the connection on the server side, WebOS will attempt to display the downloaded file. A real attacker could keep this connection open indefinitely, thus filling the device with useless data and using up the owner's bandwidth. This user is looking forward to a pretty hefty bill at the end of the month. Our next attack vector will cause a video to automatically open and stream from the internet to a user's handset. The repercussions of automatic video streaming to a user, especially underaged ones, are quite obvious. Who would want Mr. selecting video content for your child?
Oh, don't feel bad, Peter. Hey, I know what'll cheer you up. I don't think I'm in the mood. Are you sure? It's peanut butter jelly time, peanut butter jelly time, peanut butter jelly time.
Another very dangerous possibility using HTML injection is the ability to trick a user into installing a new root certificate on their device. Once a user reads the SMS message, the device will automatically download the new root certificate and prompt the user to install it. A well-crafted SMS spearfish could be created to trick a number of users into installing the certificate. Once installed, the attacker could break any SSL encrypted connection to the device and view the data being transferred. All of your online banking statements now belong to Mr. Mike Zussman, move over. These next two examples will utilize the HTML injection bug and the TEL protocol handler to automatically dial special handset codes and perform low-level handset operations. This SMS will force WebOS to open the phone dialer application and dial the digits ##633#. Many handsets have hidden codes like this which perform special functions. This one just so happens to turn off the radio of the handset. If an unsuspecting user opens the text message and places the handset back into their pocket, they might not even notice that the radio has turned off. But wait, there's more. Let's rewind a little and get that radio back on. We could have sent the key sequence pound star pound 3366 pound to the device. This will cause a quick dialog box to pop up asking the user to enable a demo. A careless user could select the option to continue and not read the warning that all of their data will be deleted. Voila! Mr. P has just deleted the user's contacts, saved SMSs, and various other pieces of personal data saved on the handset. My oh my, look at all the trouble that Mr. has caused. WebOS is just one example of a mobile platform with these types of vulnerabilities. At Intrepidus Group, we've seen many new devices which have been rushed to the market and contain similar security flaws. So why is history repeating itself? These common web application vulnerabilities have been discovered, analyzed, and taught about for years. Developers know that they exist, and they try to ensure their applications do not fall victim to the bugs. So why are they getting a new lease on life in the mobile arena? Simple. It all boils down to a few key phrases: return on investment, time to market, first mover advantage, the list goes on and on. Corporations are very motivated to get the device out to the customer as quickly as possible and work out the bugs in productions. This practice encourages cutting corners on important quality control steps, one of which includes security assurance testing. Secure your devices and know your risks. This is the Intrepidus Group. Hack on.